People are coined with the expression to see is to believe, where in order to prove something or accept something, we need to see it personally with our naked eyes or even have tangible proof in order to accept it.
In science, we do laboratory experiments and observations. In social studies, we do researches and surveys. However, in mathematics, we have these methods of proving in order to accept and prove any assumptions.
So we have three methods of proving in mathematics. First is the direct method or the direct proof. Second, the indirect proof. And third is the mathematical induction. A direct proof is a sequence of statements which are either givens or deductions from previous statements, and whose last statement is the conclusion to be proved. An indirect proof doesn't require us to prove the conclusion to be true. Instead, it suffices to show that all the alternatives are false. There are two forms of indirect proof. First is the proof by contraposition or proof by contrapositive. Instead of assuming the hypothesis to be true and proving that the conclusion is also true, we instead assume that the conclusion to be false and prove the hypothesis is also false. Second is the proof by contradiction. Like contraposition, we will assume the statement if P then Q to be false. In other words, the negation of P leads to the contradiction because if the negation of P is false, then it must be true. So this is the theorem that we will be using for a direct proof, indirect proof, which includes contrapositive and contradiction. The theorem states that the sum of the interior angles of a triangle is 180 degrees. For our conditional statement, if the sum of the interior angles of a geometric figure is 180 degrees, then it is a triangle. So we then recognize as our hypothesis, represented by P as a statement, a geometric figure with interior angles having the sum of 180 degrees, while our conclusion, represented by Q, is it is a triangle. Let us start proving this one with direct proof. To prove this, we can provide illustration to show that this statement is true. First, you must draw or construct a triangle. This triangle is named as triangle W, I, and N. As you can see, I am plotting each side or each vertices of a triangle. Vertices or vertex is formed when two sides of the triangles met. Then let us point the points on the vertices of this triangle. So we have point W, we have point I, and point N. Next, we should draw a line posing to point W and parallel to point I and N. Let us label the line passing through point W as line B and R, or line BR. Then we can have the statement line BR is parallel to line IN. Next, we should determine the angles formed. Inside the triangle, we can see three angles. Let us label it as angle 1, 2, and 3. On line BR with point W, we can also form two angles, which can be labeled as angle 4 and angle 5. Now that we already know the angles, interior and exterior, let us take a quick look in another concept in the triangle figure. Supposedly, we will cut or vertically cut the triangle. After we cut the triangle, let us focus on the half part of it. Remember earlier that we drew two parallel lines, intersecting at point W and point I. This line WI intersects two straight lines, and this is called the transversal. In this illustration, we can see a transversal line. The pairs of angles on either side of the transversal and inside the two coplanar lines are called the alternate interior angles.
Based on the alternate interior angles, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Looking back on the bigger picture, we can see that angle 2 and angle 4 are the alternate interior angles. That's why they are congruent to each other. The same rules apply on the other half or vertical half of the triangle. Then we can have angle 4 is equal to angle 2 and angle 3 is equal to angle 5. They are the alternate interior angles of the triangle WIN. To identify, let us determine the sum of the interior angles of a triangle. We have angle 1 plus angle 2 plus angle 3 equals angle 1 plus angle 4 plus angle 5. As we look back at the illustration, angle 1 plus angle 4 plus angle 5 forms a straight line. Based on the straight line angle theorem, all the straight line or straight angles are equal to 180 degrees. So we have angle 1 plus angle 2 plus angle 3 equals 180 degrees, while angle 1 plus angle 4 plus angle 5 is equal to 180 degrees. Therefore, the assumption that if the sum of the interior angles of a geometric figure is 180 degrees, then it is a triangle is proven true. Next, we will do the contrapositive proving. In this one, we need to negate the assumption, particularly both the hypothesis and our conclusion. In contrapositive, the statement P implies Q will become the negation of Q implies the negation of P. Therefore, basing on our hypothesis and our conclusion, we will have if a geometric figure is not a triangle, then the sum of its interior angles is not 180 degrees. To prove, we have the formula n minus 2 times 180, where n is the sum of all angles of the polygon and 180 is the angle of a triangle. We know that a triangle has 3 sides and 3 angles which are equal to 180 degrees. Let us use the formula to prove that if an interior angle of a figure is not 180, then it is not a triangle. Since a triangle has 3 angles, let us substitute another number to n. Suppose n is equals to 4. So based on the formula, n minus 2, n becomes 4, so 4 minus 2 will be equals to 2, multiplied by 180 will become 360. As we can observe, the polygon or a geometric figure having 4 angles is not a triangle. It is a quadrilateral. Basing on our formula, the sum of the interior angles of a quadrilateral sums up to 360 degrees. Therefore, if a geometric figure is not a triangle, then the sum of its interior angles is not 180 degrees, and this is true. And this proves our conditional statement. Then we have the proof by contradiction. To prove by contradiction, this means that P is true and Q is false. Then we build our assumption that if the sum of the interior angles of a geometric figure is 180 degrees, then it is not a triangle. To prove, we can still use the formula n minus 2 times 180. So we all know that a triangle has 3 angles, so let us substitute 3 to n to determine the sum of the angles. So 3 minus 2 equals 1. 1 multiplied by 180 equals to 180 degrees. Based on our solution, a geometric figure having 3 angles have the sum of interior angles with 180 degrees. And basing on the definition, a geometric figure having 3 angles or 3 sides is considered a triangle. Therefore, the assumption that states that if the sum of the interior angles of a geometric figure is 180 degrees, then it is not a triangle is proven false. Likewise, this assumption is a contradiction to our conditional statement. Thus, our conditional statement presented is proven true. Then we have mathematical induction. Mathematical induction is a technique which is used to prove a statement, a formula, or a theorem is true for every natural number.
This technique involves two steps to prove a statement. Step 1 is the base step. It proves that a statement is true for the initial value. And step 2, the inductive step. It proves that if a statement is true for the nth iteration, then it is true for n plus 1 iteration or number n plus 1.
Then we have our assumption 4 to the power of n minus 2 is divisible by 2 for all positive integers. To prove this one, we can refer to the process of the mathematical induction. First, let us show it for n is equals to 1,
where 1 is considered as the initial value.
So, 4n minus 2 will become 4 to the exponent of 1 minus 2 will become 4 minus 2 equals 2 divided by 2 is equals to 1. Therefore, it is proven. Second step, n equals k. So let us assume that it is true for n is equals to k.
So we have 4 to the power of k minus 2 is said to be true. So we then add 1 to k so that we could determine if the preceding numbers will also have the same assumption. Now we have 4 to the power of k plus 1 minus 2 is divisible by 2 for all positive integers. Then let us prove this one. Let us first put the value of 1 to k. So we have 1 plus 1 minus 2 equals 14 divided by 2 equals 7. Then it is proven. Then let's proceed to number 2. So 4 to the power of 2 plus 1 or 3 minus 2 equals 64 divided by 2 equals 32. Then it is also divisible by 2. Let us proceed to the number 3. Then 4 to the power of 3 plus 1 or 4 to the 4th power minus 2 is equals to 256 divided by 2 is equals to 128. Then it is also true and it is also divisible by 2. Likewise, 4 to the power of k plus 1 is also considered as 4 multiplied by 4 to the k, where 4x can be split into 2x and 2x, where each of these are all divisible by 2. To further understand this one, let us glimpse on the examples. So 2 multiplied by 4 to the power of k is divisible by 2. To see, let us substitute 1 for k. So 2 multiplied by 4 to the exponent of 1 equals to 8. And 8 is obviously divisible by 2. Basically, 4 to the power of k minus 2 is true based on the process or the solution above. Thus, 4 to the power of k plus 1 minus 2 is also true. Therefore, our statement 4 to the power of n minus 2 is divisible by 2 for all positive integers is proven true by mathematical induction. Furthermore, here is an illustration that will help us and guide us to fully understand the scenario given.
I got my head out the sunroof. I'm blasting our favorite.
So those are the various methods of proving in mathematics together with some examples. I hope you learned and enjoy. Thank you.